Welcome to this video. We're going to solve a few more textbook problems. This is a continuation of the series where I'm solving section 7.5 in the textbook Stewart Calculus Early Transcendental, the 7th edition of the textbook. Okay, we were on number 47. So we have this integral x cubed x minus 1 to the negative 4th power dx. How do we solve this? Well, maybe let me make a substitution, because something with a negative exponent I don't really like. So let's make it at least just one term, and then maybe my life will be easier. Like instead of x minus 1, let's try to make it like just x or v or u or whatever variable we want. So let's let u be x minus 1. du would be a simple dx. This is an easy substitution. So let's see what we get. We would get u minus 1 cubed u to the minus 4 du. Okay, sorry, that's a u over there. This is actually not bad because we can always expand this out and then distribute the u to the minus 4 to all the terms. And then it'll just be power rule everywhere. Okay, there might be another way to do this problem. I don't know, I'm just going to do it this way. Okay, I feel like this I was able to see right away. So let me just finish where I started. Okay, so let's expand this guy out. So let me just do it the long way. So if it's u minus 1 squared, it'll be u squared minus 2u plus 1. And then we still have one more u minus 1, and the u to the minus 4 du. Okay, so now let's expand these two. It'll be u cubed minus 2u squared plus u minus u squared plus 2u minus 1 u to the negative 4 du. Okay. Let me double check. U cubed minus 2u squared plus u minus u squared plus 2u minus 1. That looks right. Okay, so let's combine some like terms. U cubed minus 2u squared minus u squared minus 3u squared plus u plus 2u, so plus 3u plus, minus 1. All right. This looks right to me. And the u to the minus 4 du. Remember, if you expand a polynomial like this, if you remember the name Pascal's triangle, or really Pascal's triangle is just the binomial coefficients or something like that. So if you remember those, even better. Okay, but I just did it the long way. Okay, so now let's distribute this u to the minus 4 to all the terms. So it'll be u to the minus 1 minus 3u to the minus 2 plus 3u to the minus 3 minus u to the minus 4 du. This is all power rule now. So it'll be, this is just log, right? Log of u plus 3u to the minus 1. If I differentiate, it'll be minus 3u to the minus 2, which is the same as there. Here would be minus 3 over 2u to the minus 2. Okay, because if I do differentiate this, once again, it'll be plus 3u to the minus 3, which is there. Okay, and then plus third u to the minus 3. And then if I differentiate this, I get minus u to the minus 4, which is there, right? Plus c. When I'm almost done, back substitute. Log of x minus 1 plus 3 over x minus 1 minus 3 over 2 x minus 1 squared plus 1 over 3 x minus 1 cubed plus c. That's what I get. Okay, and as I said, there might be another way to do this, but I saw this was doable, so I just did it. Okay, it all became powers, which is just easy power. Okay, next. Integral from 0 to 1 x square root of 2 minus square root of 1 minus x squared dx. Okay, how do we solve this? Immediately, because I see a square root under a square root, maybe let's try to substitute and get rid of that square root. So 1 u is square root of 1 minus x squared. Maybe let's try substituting that. Okay, remember we can always square it. U squared is 1 minus x squared. Differentiate from here to u, du is minus 2x dx. Or we can say u du is minus x dx. All right, so our integral becomes, let's worry about our limits afterward. We have x dx on the outside, actually. So it's just minus u du. So minus u and a du over here, let's say. And then square root of 2 minus u, as simple as that. Okay, now let's do our limits. When x is 0, we can plug into here. U is 1. When x is 1, u is 0. Okay, so we can get rid of the negative sign and flip our limits. How do we solve this now? Well, I can make another substitution. V is 2 minus u. dv is minus du then. Okay? We'll worry about limits again afterward. U would be 2 minus v. Okay, and then we have square root of v, and then minus dv. Okay? Limits, when u is 0, v is 2. When u is 1, v is 1 as well. Okay, so again, we can flip our limits and get rid of this negative sign. So integral from 1 to 2. And let me distribute this square root v to both terms. So it would be, let me even, write it as exponent. It would be 2v to the half minus v to the 3/2 dv. Again, this is just power rule now. So it would be 2 times 3 over 2. 2 times 2/3 v to the 3/2 minus 2/5 v to the 5/2. We evaluate this from 1 to 2. So this is what? 4/3 times 2 to the 3/2 minus 2/5 times 2 to the 5/2 minus parentheses 4/3 minus 2/5. This should be your answer. Okay, so once again, let me recap what I did. Of course, double check my work. It was a square root and a square root on the inside of that square root. So maybe I was thinking, let's try to substitute this as just one single variable. U is square root of 1 minus x squared. So I did my usual step of squaring both sides, and then I differentiated from there. And here I can simplify. U du is minus x dx. So x dx is u du with a negative sign. Okay, so that's what I did there. And then this becomes square root of 2 minus u. Okay, and I made another substitution after I flipped the limits. Made another substitution. V is 2 minus u. And then this became simple because I can distribute this. And then it's just power rule. Okay. And then let me do one more in this part. I probably only have time for this one other problem. Okay, so how do we solve this one? So let's go down our list maybe. Do I see a substitution? Not an obvious one that I can see. Because if I let u be square root, du would be 1 over 2 square root of blah, 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 right? It might work, but let's hold off on that. By parts, I kind of don't want to do that because it's the product of 1 over x and 1 over square root of 4x plus 1. It might get very messy, so I kind of want to avoid that. It might be doable though, but let's hold off on that. Not trig integral, trig sub, it's not something squared plus something squared, so probably not that. and it's not a rational function for to do partial fraction decomposition right now. Okay, so maybe let's try substituting something. So maybe let's actually do that substitution I was saying. U is the square root. Okay, I'm not sure if we'll get anywhere, but let's just try it. See if we can clean up some things. Make it look like one of the techniques we know how to do. Okay, so as always, let's square it. U squared is 4x plus 1. So then 2u du would be 4 dx, or u du would be 2 dx. Okay, so let's substitute. Dx is half u du. What is x? X would be, we can get it from here, u squared minus 1 over 4, it would be x. So u squared minus 1 over 4 times square root, which is just u. Okay? So we get this. Now let's simplify a little bit. We see that these would cancel. We can move this 4 up on top, so we get 4 times half is 2. 2 integral of du over u squared minus 1. Okay? And now this is partial fraction decomposition. I believe I saw this in a previous video, but I'll do it one more time. We can break it up as a over u plus 1 plus b over u minus 1 is equal to 1 over u plus 1, u minus 1. Okay, multiply both sides by the denominator, a u minus 1 plus b u plus 1 is equal to 1. I'm going fast here because I've did this before. Okay, and you can always watch my crash course video on partial fraction decomposition. Okay, we plug in u as 1 because this will go away. 2b is 1, b is half. U is minus 1, we plug in. This will go away. Negative 2a is 1, a is negative half. Okay, so we get 2 integral of a is minus half times 1 over u plus 1 plus half times 1 over u minus 1 du. I just plug it into our partial fraction decomposition with our a and b that we found. Let's distribute the 2 to both terms to make things nicer. Be minus 1 over u plus 1 plus 1 over u minus 1 du. This is just minus log of u plus 1 in absolute value plus log of u minus 1 plus c. Back substitute. What was our u? It was square root of 4x plus 1. Okay, and that's my answer. Of course, double check my work to see if I'm correct. This should be a plus. I don't know why we're a minus there. Okay, so hopefully this is helpful. Please like this video if it was. And please subscribe also if you have not. And please look out for the next video where I'll solve the next few problems. Hopefully I'll see you there. Bye.